Alright, so when variables are first created, whenever you declare your variable, you don't know what it's containing. It's got a memory address and it's pointing somewhere, but you don't know where it's being pointed to because the compiler picks that. So you absolutely do not know if it's got a 0 in it or not. Now I believe that our compiler, I think we tested it, shows it as being an error if you try to use an uninitialized variable. However, it's just flat out not safe to use a variable without making sure that it's got some data in it. So just assign them 0 when you create them, if nothing else. So you can declare your variables and then initialize your variables, or you may as well just initialize them as you create them, right? We could have done this, that, and that, or this is the same thing actually. If you put a single quotes here, and then a \0 and a single quote there, that means the same thing. This is the null character, right? And you only need to do that if it's actually a char data type, not an int or a float or anything else. So printing variable contents. After you declare your variables and you initialize them, you can print them out. %d is for floating point. Excuse me, %d is for integer. You know what I wish is that that was %i for integer, but I didn't make the language. I was only 3 years old when it was published, so I didn't have a say. So it's %d to print out an integer. It's %f to print out a float. It's %c to print out a character, and %s, which isn't shown, to print out a character array or a string. So if you have int x is equal to 0, float f, and I think I've said don't bother using float if you have doubles available to you, equals 1, and you have char ch equals single quote 2, and then char ch, you're creating a character array, and it's got the word 3 in it, and you want to print all 4 of those things out. Heck, let's type this into Visual Studio, get it going. Or at least an online C compiler. We could start using an online C compiler if we wanted to. Then we just have to copy and paste our notes when they're done, and I'd be afraid I'd accidentally close the window and lose it. So new project, this is C underscore, for me, I'm calling it C underscore, you don't have to because of the C++ class as well. Lecture F. Now I need to do View Solution Explorer, so I can create a new file, add new item, and this is lecture lecture F. And I'm going to go grab my boilerplate. There we go, there's my boilerplate. So I'm going to create 4 variables, just like I was in my notes. Int I equals 1. Long, L, I hate using that. Li for long I equals 2, or 2L, doesn't matter. Float F equals 3F. Double D equals 4. I seem to be getting an error here. Let me check, see why. User defined literal operator not found. Well, maybe I'm thinking C++. Why is that not working? Okay, fine. Leave that alone. All right, we've got those variables. Let's create a character. CH equals, and it's a character, so we've got to use single quotes around it. And now we're going to make a string. A string is an array of characters. So S, short for string, square brace, in square brace, equals quote 6, end quote, in semicolon. Now we're going to print those things out. Print, parentheses, quote, %d is for ints, %ld is for longs, and %f is for floats, \n, end quote, comma, I, comma, li, comma, f. So now I printed the first three, right? I forgot my semicolon, but printf. Whoops, that was supposed to be printf. I think I said printf and didn't type it. Maybe not. That's definitely supposed to be printf. Now I'm going to print the last few things. Printf, parentheses, quote. A double should be a %lf, or else you'll get a warning. It'll still work if you do %f, but it gives us a warning, so let's get rid of that warning. A %c for a character, %lf, %c, and %s for that string, \n, end quote, d, comma, ch, comma, s. Let's run it and see if that works. All right. 1, 2, well, that did not print 3, 4, 5, and 6. What did I do wrong with that float? Why is it saying that float's a 3? Isn't that interesting? What if I actually set this to 3 here? Is it going to print the float then? Not yet. What if that was 3.0? No. What if this was just %d? No. What if this was I'm quite confused as to why it's not printing out my float. Well, it printed that one out. Okay. I'm doubly convinced to never use a float variable. Just never going to use a float. So I'm deleting that float f thing, and I'm deleting this part of the print statement. I'm boggled. There. So now this line just says %d, and I'm getting rid of that last part of the print as well. %d, %d/n, I, comma, li. I'm going to go back and put that L there because, strictly speaking, that was correct. LD for longs. All right, looking better. I don't know what is up with that. Okay, it's giving me one warning. Let's see what that warning is. LD requires an argument of type long, but variadic argument 2 has int64. Well, if you're going to give me errors anyways, I'm going to get rid of the %d. Excuse me, the %l. Yeah, whatever. What this is telling me is that this variable was declared as a so-called int64, which is an 8-byte int, which is what I wanted. But apparently it doesn't want. What are you supposed to do? Put 2 L's there? Are we seeing a difference between Microsoft C and... Yeah, that got rid of it. What do you know? Alrighty, that looks really stupid. %LLD looks really stupid. You can just make it %D and ignore the warnings. That's cool. %D and %F for printing floats, or %LF for printing doubles. They both will work. We're not going to get any syntax errors out of that. We're just getting some warnings, and we're going to ignore those warnings. If we really, really, really hated those warnings, we could add them to our ignore list. C4477. I could come up here, copy, paste that, and disable 4477. just to say I'm sick of seeing that error. And now when I go and look at the error list, it's gone. All right, that makes me happy. I'm going to put a comment as to what we're getting rid of here. Hide the percent D for long error. Warning. Or int64 warning. That's what I'll say here. int64 and int32 are Microsoft variant data types to specify whether you want a 4-byte int or an 8-byte int very explicitly. But we're not learning Microsoft C, we're learning C in general. Alrighty, onward. So %D displays ints, %F displays floating point numbers, and %C displays character. When you print out a floating point number, you can specify how many decimal points you want. Like right now, I don't know how many decimal points that's printing. Let's run it and see. But that first number for D has got, I don't know, 6 decimal points. What if we want it to only have 2? We make it say %.2. That displays 2 places after the decimal point. So all I did is add the %.2 between, all I did is add the .2 in between the % and the F. So if I want 1 decimal point, I can do that as well. %.1F. Like that. And this is just going to demonstrate. It's going to print 3.1 because of the %.1. It's going to print 3.12, 3.123, 3.1234, except it'll actually probably print out 3.125. My guess is that it's going to round up. We can try that out. I'm going to set my variable up here, F, equal to 3.123456, and I'm changing this to a 4F like in our example, just to see if it rounds up that digit to a 5 or not. Yeah, it did. It rounded it up. So %C is for characters. A named constant is a read-only variable whose value cannot be changed later in the program. Meaning that if I made one of these a const, if I decided that D had better never change later on in the program, if I want a syntax error when I try to change it, I could flag it as being a const with the const word. And then later on, if I try to, by mistake, change that to something else, that's going to be a syntax error. And as a matter of fact, we see it underlining it, and it says expression must be a modifiable L value, meaning that the left-hand side of the equal sign has to be a modifiable variable, not a read-only variable. The const made it a read-only variable. I'm going to add a comment to the effect that error because D is read-only. So why do you use const? Just to make sure that you're writing your code in such a way that later on, if you come back to it or if somebody else edits it, they don't make changes that would conceivably break the program. If it would break the program for the value of this to change after it started running, then you want the compiler to tell you so. Flag it as an error if the code was about to change it. So when learning how to program, consider at least 2 areas to develop a consistent programming convention and style. White space and variable naming conventions. So here's one idea. Identify your data types with a prefix. What does that mean? They mean, and not everybody does this, that if you have a variable that's an integer, name it with an I at the beginning, like this. Int I age equals 19. I'm 19 years old. Int I heart rate equals 80. That kind of stuff. Double space D, I don't know, average equals 87.5, whatever. When you look at a variable that's named like this, by the way, that's called the Hungarian notation, even if the textbook doesn't call that, just because the guy who invented it was from Hungary, and so the people who worked with him at Microsoft teased him about his variable names and said they were in Hungarian. They were actually a little bit more cryptic than this, but the first letter means the data type. Now that's kind of almost passe because, anyways, not a bad idea. Programming style, this book recommends doing that. That's fine. I'm not going to count you off if you don't. Use uppercase and lowercase letters appropriately and give the variables meaningful names. I heart rate would be a lot better than just calling it I or R. A good variable name makes the code readable. Makes it less likely that if I come back in and change it, I'm going to accidentally try to use that variable for something else, because maybe I'm real used to using I as just a counter, right, to go from 1 to 100. And then it turned out that somebody else had chosen to make I something important, like the heart rate. So try to give your variables good variable names, and I know I've said this in the past. I use single letter examples in our code up here just because it's easier to type. Fewer syntax errors mean we cover more ground. So regarding identify data types with a prefix, take it or leave it. However, if you're using pointers, using P for it is universal. Well, we don't know what a pointer is yet. I may as well demonstrate it since they just showed it, but I'm not expecting it to burn it into your brain yet. Here's what a pointer looks like. Int asterisk pH equals ampersand IH. What this means is I want to find out the address of the IH variable, and I want to store that somewhere so I can do something with it later. Well, the ampersand means give me the address of. And so if I printed out pH, it would give me the address where IH was stored. May as well. Printf parentheses quote pH, the pointer to the age variable, equals %d \n, end quote, comma, PAGE. And now when I run it, I'm going to see what memory location on our computer that age variable is being stored at while it runs. All right, 1,500,000,000, whatever that is, right? Normally we don't need to know that, but you can use a pointer to actually change the value of the data without even changing the variable itself. Age right now is 19, right? And what if I do this? Star pH equals 99, and then I print out the age variable. So here I changed the value of the data at that memory location. I never changed IH, but if I print IH out, printf parentheses IH equals %d \n, end quote, comma. If I print IH out, so after the comma, I'm going to put IH, greater than, excuse me, close parentheses, semicolon. We're going to see that even though I never changed the value of IH, right? I never touched IH all the way down here. I just got its address. IH is now going to be 99 when it runs. Like that. So pointer means I have the address and I'm going to change something by the address. It's like if I hand you my street address, you can go over to my house and you can paint my house green, right? Even though you don't own my house, you can use the address to go over there. Well, this is using the address to change that data. without owning the variable, right? Here's the variable that owns that data, but then we use the address to go and change it. We drove to my house address and we painted the house green. So when we print it out, it turns out that age is equal to the new value here and not the old value here. So this is demonstrating pointers. And like I said, I don't really care at this point if you got that 10% or 100%. This demonstrates using a pointer to the iAge variable to change the data without touching iAge. That's all that does. And let's put a comment to the effect of, you should name your pointer variables with a P prefix, just starting with a P. Now, we're not going to talk about pointers again for a while, so we can forget that, but wanted y'all to see it. Pointers are kind of unique to C and C++. You're not going to see them in Java or Python or a lot of other languages. And so those languages leave it out because if you make a mistake with your pointer, you can cause your computer to, well, you can cause the program to crash. It used to be you could actually crash your whole computer. Now operating systems are a little bit more secure. But let me show you that. Let's see if we can break our program by using a pointer incorrectly. Our variable is called page. What if instead of using this syntax for trying to change it, I had changed it like that? And then later on I remembered, oh yeah, ph, I tried to use the same syntax. Let me change that to a 0, see if that works. Yeah, okay. So I'm going to add those 2 lines of code. And for reasons that we don't know yet, this is a terribly bad thing to do. Boom. It should have blown up. It says exception thrown. Exception thrown. Write access violation. Page was null pointer. That's a lot of fancy talk for saying that it was trying to change memory it does not own. It was trying to change address 0, the very first byte in your computer. Now, your application is not supposed to have access to the very first byte in your computer. It's only supposed to have access to the couple of bytes that were allocated to your program when your program ran. So, Windows stops us from doing that, which is a very good thing. We only want it to kill our application rather than to break the operating system or cause the computer to crash. Okay, I'm going to delete those 2 things. But that was a demonstration that using pointers can cause your program to crash, and sometimes it can be pretty subtle. Maybe it won't cause your program to crash. Maybe it'll just cause it to behave a little wrong under certain circumstances. It can be really hard to track down, so languages like Java and Python did away with the ability to access your memory by address. In those languages, you can only access your memory by their name, by changing iAge itself and not doing some voodoo here to change it by its address. Let's get rid of those 2 statements. Unless we just want to leave them there. Note that it causes an error. Let's get rid of them. So this is suggesting, alrighty, I'm going to start all my characters with CHR. I'm going to start all my floats with FLT. Now that's a little bit zealous. When I was doing this professionally in teams, we would just use F. That was enough. INT, just calling it I is enough. CHR, okay, that's fine, but you could just use CH. STR name, I saw either that or SZ, meaning 0 terminated array. I remember showing you that if you have something like that, there's a secret 4th character which is just equal to a 0. And if we printed them out by their ASCII values, we would see a 0 there. And so this means 0 terminated string. Really didn't see people put the whole word there. You could. By the way, you may have noticed that when I was declaring my string in the code, I didn't put a number between those square braces. If you don't, it means use up exactly enough memory to hold the data that I specify, which in this case is 4 bytes. Why 4 bytes? 1 for the S, 1 for the I, 1 for the X, and 1 for the invisible 0 marker at the end. So 4. But what if I decide I might want to change the contents of this string? I might want to put a longer word into it. Well, if it's only 4 bytes long, I better not put anything that's larger than 4 bytes into it. But I could specify a larger value here. I could say, okay, I may hold words that are up to 19 characters long, plus the 0 at the end. I'm going to leave myself space for 19 letters, plus the terminating 0. If I leave that out, it just matches this exactly, just enough to hold this. If you specify a number, it gives it extra room, so if you want to copy some more data into that string, you can. Well, what would that look like? Let's declare a new character. We're going to do just a little bit of string manipulation. Char space S or SZ first name, square braces. Let's say that no name is going to be more than 20 characters. So inside the square brackets, I'm going to put 20. And it's a good idea to initialize it, even if you're going to fill it in later, because otherwise when you printed it out, you get something funny looking. As a matter of fact, let's see what that something funny looking might look like. Let's try printing out the first name. Then we'll change it, but we're going to use a printf. And what did I say the % placeholder needs to be for a string? Just like %d for an int and %f. Yeah, we need an f. Excuse me, an s for a string. So printf first name is %s \n end quote comma sz first name. Oh, and if you get into the state where your start debug option isn't here, it's because it's running in the debug and it crashed or it paused. The best thing to do is just to find the little red stop button here, or it's also probably under the debug menu. Stop debugging. Then we can run it again. All right, is that my first name? This is a great example. The memory was not initialized to anything useful, so it's an array. It's an array of characters. It's a list of characters, but who knows what memory address that's pointing to. And the compiler did not take the time to wipe out that data so that it looked anything other than that. But let's put some good data in there. What we should do is whenever we initialize a string array, is set it equal to an empty string so that if we printed it out, we wouldn't get pure garbage. Yeah, that's better, but wouldn't it be better if we actually had some data in it? We're going to use a copy function to put some data in it. str for string, str cpy. I'm not seeing cpy in our choice here. Here I am going off the map again. String copy C. It's supposed to be there. Oh, I need to include string.h. And I need to add that to my boilerplate, honestly, so that it's there every single time I do this. So scroll up to the top. We're going to add another #include. #include less than string.h greater than. And I'm going to go and modify my boilerplate just so that I don't forget to do that again. So there's my boilerplate. #include less than string.h greater than. And I had this warning here, and I'm not going to worry about the warning. All right. Now when I finish typing that code, that string copy code, it's going to recognize it. str cpy parentheses sz first name. That variable is a little too long for my typing pleasure, but as you start typing it, at least it pops up this little list here that you could click on to choose. And then let's put, you know, I don't know, Beyonce as our first name. end quote, in parentheses, semicolon. Now when we run it, it's going to copy that string into the first name string, and so it prints it out nicely. You get into trouble if this is longer than this, right? How long is this string, including the 0 terminator at the end? It is 1, 2, 3, 4, 5, 6, 7. Plus the 0 terminator is 8. So if this was less than that long, like if it had only been 4 because we had set this equal to Bob, we would be writing past the end of the string. We'd be overwriting some memory that this variable doesn't own, which is bad news. It should throw an exception and the program should crash. Now, magically, it did not. It's weird that it did not, but that meant that it changed some data in the program incorrectly without warning us. And who knows what would happen later. The program could run perfectly. It might give you the wrong answer immediately. It might fail 1 time out of 10. Oh, here it is. Now it's telling me exception thrown. Runtime check failure number 2. Stack around the variable SZ first name was corrupted. That's saying that it wrote past the end of the variable, of the data. There was not enough space allocated to it because 4 is not large enough to hold this. I'm going to change that back to 20. And I'm going to change this back to an empty string. There are safe versions of string copy that should not be able to cause an exception when you use them. String in copy, but it says that that's not even safe to use. Are they giving an example of what to use instead? Why should you use string in copy? Okay. Here's the safe way of doing it. str in cpy, parentheses, SZ first name, comma, Beyonce, end quote, comma, and how many characters do you want to allow me to copy? Well, if the length of it is 20, I better not copy anything more than 19. Honestly, I would have made that 21, right? Just to make it a round number so that I could specify 20 there. I don't like it, that offset, but anyways, there we go. This says that even if this string is longer than 20 characters, don't do it. Only copy the first 20 characters. Well, let's prove that by only copying like the first 2. If we only copy the first 2, we're going to see B and E in our output. Because we've said just go 2 and then stop. I need to stop my debugging. Getting the idea, I better stop and wander around. I may have people with syntax errors who haven't thrown a shoe at me to stop me yet. All right. So when I run it, ooh, it still says first name is equal to Beyonce. Well, what if we did something else? Who's she married to? Jay-Z. All right. We're going to copy Jay-Z in there. And it printed out first name is just as a little bit weird, and we're going to get off this topic real fast, but it printed out Jay-Z Beyonce. Why in the world did it print that? Because we told it to copy the first 2 characters in. And when we copied the first 2 characters in, the rest of it was left alone. And it doesn't matter how much data we put in here. Like if I make it Jay-Z like that, now it's only going to put the J and the A there. Even though there's a Y and a Z, it's going to forget those because of the 2. That's about enough of a topic that we've hardly even hit in the textbook, so we're going to stop there. So programming style includes picking good variable names, putting white space where it needs to be, tabbing, making a personal decision about where you're going to put your braces. What do I mean by that? A lot of people do this. I'm just going to type something stupid. If 3 is less than 4, in parentheses, then int xyz equals 5. Right, something stupid. There we go. That's one way to do it. Line up the braces like this, or do it like that. I prefer that style. However, the people who invented the language chose to do that. Also, the people who invented the Java programming language like to do it that way. You're going to see a lot of code examples out on the internet that look like that. You're going to see a lot of code examples that look like that. Just depends on which one you think is easier to read. I like seeing the angle braces there so I can line them up. You'll find that as you program in C, it gets real easy to mess up the placement of your angle braces. Even though this editor kind of gives you those dotted lines to kind of give you a clue, you can still run into trouble trying to get them to line up. So that's how I like to do it. Your choice. Here's what I ask you not to do. Don't just not use tabs. Or don't use tabs that are messed up. Take the time to fix it. If your data gets all, if your code starts to look all goofy and lousy, select everything, edit, select all, and this is on the Windows editor. The Mac editor users are going to have to do something else. I don't know how you do it, but I'm sure the Xcode does it. Edit, advanced, format. And then it fixes it as good as possible. Right, so our tabs are kind of fixed now. So personally, I use G underscore to denote global variables. Well, that guy and I must have worked together, because that's what I did too. What's a global variable? A global variable is one that's declared outside of your functions. We have a main function up here, but I could declare a variable above it. Why would I want to do that? Because otherwise, if I declare a variable inside main, any other function is not going to be able to use it. Let's give an example of that. What if I write a function called times 2 or square, which takes a number and multiplies it by itself? Takes an integer and multiplies it by itself. int space square parentheses int I into parentheses curly brace int result equals I semicolon return result. Now this variable here, result, is only declared inside this function. So if I tried to print it out, if I tried to do int xxx equals result here, that's going to be an error. It won't compile. This is locked inside this room. Right? This fridge is in my apartment, so my next door neighbor in their own apartment is not going to be able to get to my fridge. This variable is local to this function, meaning it's not accessible inside another function. That's called being in scope. This variable is in scope from where it is declared all the way to the last curly brace in which it was defined. But as soon as it hits that curly brace, it's no longer defined. If I really wanted to share a variable between two functions, and this is not considered great programming, but it's possible, I can make a global variable. Int G result, or G underscore result, equals 0. And then I could do this. G result equals I times I. I think I left off that I times I part. I think it wasn't returning I times I. And then return G result. It wouldn't even have to return it in this case. But it wouldn't be correct until we called it. And so now I could do int ABC is equal to G result. And if this function had ever changed it, it would equal the new value. If this function had never changed it, it would still equal 0. Like I said, that's real bad. No, I won't say that. That is real bad programming. It can make code more difficult to understand if you have global variables. It's generally frowned upon to use global variables for anything other than constants. So I'm going to go back to the way that it was and make this an int right here and make it say int result equals I times I and then return result. There. But this is a global variable. Let's add a comment to that effect. Global variable. Let's add a comment. Global variables can be shared between functions, and local variables are only good inside the function in which they are declared. Use G underscore to name your global variables, just because a lot of other professionals do. You don't gotta. Code would work if it didn't have that G underscore. Is our code still working? Anybody need typing time? Slow down? You got it. All I did is add some comments. That's the only stuff that I added. So if you want to type it. If you don't, it'll still be in the notes. Or I'll print it out. You can have it at the end. So we ready to go on, or you go, okay, all right. So Scanf. I showed y'all Scanf last time. You use Scanf to let the user type in something. Normally, we're going to use a %d to get an integer, or %lf to get a double, because those are going to be the two most common data types we use. Or %s, which they don't seem to show, to hold a string. Well, they show it there, but they don't show it there. %s receives string. There. Wish that was there. If I remembered to upload it, that would be good. When you're using %, you can tell it how many characters are supposed to be devoted to which variable. Like the first 7 characters it reads are supposed to be stored in an integer. And then the rest of that data, until it hits a space, is supposed to be treated as a string. Until it hits a string, a new line, or a tab. And then it's going to read a non-white space character. And then finally, all the rest of it's going to be treated as this double. Now, that's a bit weird. We'd better get some examples going before we can dig what's going on here. I'm going to scroll back down to the bottom, I guess, of my system pause. Let's declare 3 integers. Int I1, I2, I3. Let's set them all equal to 0 just to begin with. I1 equals I2 equals I3 equals 0. Now let's tell the user type printf parentheses quote enter a number in the form xxx yyyzzz \n. Normally, I don't think I would do this. I wouldn't tell the user to enter 3 numbers in a format without spaces. Well, it'll work. All right, now scanf, parentheses, quote, %3d, 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 end quote, comma, ampersand I1, comma, ampersand I2, comma, ampersand I3, close parentheses, semicolon. What this means is the first 3 things they type, the first 3 digits they type are going to get stored in that variable. The second 3 digits they type are going to get stored in that variable. And the third 3 variables they type are going to be stored in that variable. Now let's print that data out. Printf, parentheses, quote, %d, space, %d, space, %d, or maybe some commas. I don't know what would make it look pretty. %d, comma, %d, comma, %d, \n, end quote, comma, I1, comma, I2, comma, I3, closing parentheses, semicolon. Now this is going to require the user to type the data in exactly right for it to work. What do I mean by that? If we don't give 3 digits for each number, 1, 1, 2, 3, 3, 4, 5, 5, 6, okay, it worked that time. 1, 1, 2, 3, 3, 4, 5, 5, 6. It read those 3 numbers in. What if we don't follow the instructions correctly and we just type in 1 space 2 space 3? Okay, fine. Make a liar out of me. That worked. What if our data was too large? One, 2, 3, 4 space 5, 6, 7, 8 space 9, 8, 7, 6. There, goofed it up. Because we were telling the program exactly how many characters were supposed to go into I1, exactly how many went into I2, and exactly how many went into I3. Normally you don't do that. Normally you just let them type in numbers separated by spaces. Printf, parentheses, quote, please enter 3 numbers separated by spaces, \n, end quote, in parentheses, semicolon. Now the scanf is going to look similar, it's just not going to have those 3's between the percents and the d's. Scanf, parentheses, quote, %d space, %d space, %d, end quote, comma, ampersand I1, comma, ampersand I2, comma, ampersand I3, close parentheses, semicolon. What are the ampersands for? Just like when we talked about with pointers, this gets the address. We have to pass the address of that variable into the scanf function so it knows where to write in memory to pass the data back. And let's copy and paste that printf statement so that we're printing it again. I'm going to copy that print statement, just shift down arrow, Control C, Control V like vehicle to do a paste. Alright, enter a number in the form XXXYYYZZZ. 1, 2, 3, 4, 5, 6, 7, 8, 9. And enter 3 numbers separated by spaces. There, more flexible, right? But if you ever had to open a file and read it character by character and you knew the first 3 bytes were part of this number and the next 7 bytes were part of another, then you could use scanf in that function. Alright, I hadn't checked my error list in a while. If we come over here and rebuild the build, rebuild solution, and I click on my error list, I'm going to see some additional warnings. We're going to explain them and then we're going to talk about why we ignore them. Oh, fine. Yours is showing warnings and mine's not. It's complaining that something returned from scanf is being ignored. The scanf function returns a value. If I highlight scanf and I click F1, it'll take me to some documentation about it and what it returns. But nobody ever catches the return value to use it. So it's a really, really trivial thing. In fact, this thing's not even saying it returns anything. Return value from scanf. It returns the number of successful inputs. It returns 0 in the case of an error. So we could do that.
Professor Johnson,
Yes.
I noticed on the miles per hour and BMI homework, when I typed my scanf in, it gave me an error, but it gave me a suggestion.
Okay.
It told me to use scanf _S.
Underscore S.
And it seemed to take it.
Seemed to fix it. That definitely sounds like good advice. Scanf underscore S would be a safe version of scanf. Let's highlight it, click F1, and read the documentation about it. Reads formatted in data, have security enhancements as described in security features. Many old CRT functions have newer, more secure functions. If that's the case, then when you do your old function, you may get a warning about it or even an error. The security functions do not prevent errors, but they can catch errors as they occur. For example, string copy has no way of telling if the string that it is copying is too big. We've already talked about that, like when I was copying Beyonce in, but it was too short to hold the answer. However, its secure counterpart, string copy underscore S, takes the size of the buffer as a parameter, so it can make sure that it doesn't go past it. So, yeah, if you're getting an error message about using scanf, use scanf underscore S. It sounds good to me. The other thing that you might get warnings on is it may say return value ignored. And I would think that we're all using the same version of Visual Studio, so I'm not sure why one student's getting this and the other not. But if we wanted to fix that, if we wanted to make that error message totally go away without coming up here and adding yet another ignore up here, then you could do it like this. I'm just going to declare some variable to hold the results of the scanf. And I'm going to say scanf. I'm going to say results equals scanf. And I'm going to print out the results just so that we can see what they are. Printf results equals %d \n end quote comma results. And it should be 3 because we filled in 3 variables. If we had 5 variables, it should return a 5. If it returns a 0, it means that no data was read. 111, 222, 333. Please enter 3 numbers separated by spaces. Well, what if I only type in 2? Oh, it's forcing me to type in a third. Okay. Results equals 3 because it read 3 things. So, if you're getting a warning message and you don't like seeing that warning message, you can just declare a variable and you can stick results equals in front of all of your scan statements. You can just put that in front of every single one of them. You can just ignore those results. You don't even have to check it. On the other hand, if you don't mind seeing the warnings, don't bother. So I'm going to go ahead and get rid of those. And you're saying, but you just made me type them in. Okay, I'll leave them. I just undid that change. People don't normally store the return value of scanf into a variable, but you may get warnings about scanf return value being ignored. If so, and it bothers you, declare a temporary variable, declare an int variable, and use it to hold the results. Int ret equals scanf blah blah blah. That would make the error go away. That would make the warning go away. If you get an error saying scanf is unsafe, then use scanf_s instead. Thank you for reminding me that. I don't know why I'm not seeing that. All right. We need to wrap this up. See if we have one more homework assignment waiting for us. All right, there's a Dropbox for Lecture F. Just go ahead and upload Lecture F to it. We decided not to do any homework this time, so finish up your prior assignments if you still have any left to do, and I'll see y'all on Monday.